Okay guys, so tonight you are doing a lesson on your own, watching this video, filling in your note sheet. Tomorrow I will be looking at your note sheet and that's what you'll get your points for homework for. So we can start out by defining what a system of equations is. A system of equations is two or more equations that have the same variables. A linear system now is exactly two equations where we have two of the same variables, and it's usually x and y, especially when we're graphing. But it could be a, b, or other letters depending on if it's an application or not. A solution to the system then, what you can think of is it is either the ordered pair, x, y, that makes both equations true, and it has to be true for both, not just one. Or if we're thinking graphically, it's the intersection of the graphs of the two lines, of the two equations. Okay, so solving by graphing, we could have one of three different ways. We could have where the points, or the point of intersection, or the solution is an intersection. Here's some new words for you. So we have consistent. This would be a consistent system. It means that there is a solution. This system with one intersection would also be considered independent because it has a unique solution, only one solution. Okay. The other way we could have two lines land on a plane here is it lands right on top of each other, or they're equations of the same exact line. That would be infinite intersections. That is a consistent system because it does have a solution, but that one we would call dependent system. Okay. It's dependent because there are infinite solutions, and it's depending on the line. Be careful here with the equations that make the same line. You have to think about this. Every single point that is on the graph, for example, like these points, would not be solutions. So these are not solutions. The only solutions that you have to the system are every point on the line. So you have to be careful when I ask you what is the solution. So if I say what is the solution, if you just write infinite solutions, that's not the answer. Okay? That's answering the question how many solutions there are. So that's not the answer. What we need to do is we need to actually state the solutions. Oops, can't spell. And I'll show you how to do that in a second. So just be careful. This is a different kind of case. We have to make sure we're actually stating solutions and not how many there are. But anyway, back to the third case. Now the third case is if I have two lines that are parallel, that there's no intersection. If there's no intersection, there is not a solution, so that's what we would call inconsistent. Okay, so an inconsistent system means there's no solution. So we can classify using two different words, consistent or inconsistent, and then dependent or independent. Okay, so we can try a couple here. Basically what I have to do is I have to graph the two lines and find the intersection. So this first line here, I'm going to think about my intercept. So my x-intercept would be 2, 0, and my y-intercept would be 0, -4. So I'll put that on. You should be using a straight edge, but I can see that it would be something like this. I'm not using a straight edge just to kind of save time. Here, if I solve this one for y, I'd have y equals 2/3 x. So this one I have intercept of 0 and then up 2 over 3, up 2 over 3. So I can see, straight edge would be good. I can see where my solution is. Now be careful, I have these equations graphed and I can see the intersection, but this is not my answer. My answer has to be written as an ordered pair, so I have 3, 2 is my ordered pair, it's consistent, and it's independent. Okay. Another example. Here, if I graph the second one, I have the intercept of 2, 0 and 0, 2. Hopefully you're feeling okay about standard form graphing. And I can see that I actually have a slope of 1 here. and then if I graph the other one, maybe I'll graph the other one in a different color, so I'll graph this one in pink. I have an intercept of 2 and a slope of -1. So at this time, I can see that the lines are actually on top of each other. Okay. I know there are infinite solutions, but not every single point is a solution. For example, this is not a solution, but say this point here is a solution. So this is not, this is, if you think of it like that. So I need to figure out a way to state all the points on the line. So this is how we do it. We say ordered pairs x, y, such that they make one of these equations true. And you could just list one. It wouldn't have been wrong to list it like this way. X, y such that this equation works. You just pick one. You don't need both of them, so this is an or. Okay? This is a consistent system because there is a solution, but this time it's dependent. It's dependent on the line. Just the points on the line make the system work. Okay, so my last one here, again, I can do ordered pairs, I can do intercepts. So here, if I solve for my x-intercept, I have -2, 0, that on. And then I have 0, 1, put that on. I can kind of continue my slope, know where it's going to go. Okay. Second line here, maybe I'll solve this one. Oops, this is x -4. So I can graph this one. I have a y-intercept of -2, a slope of 1/2. And I have the same slope and parallel lines. So I have no solution. This would be an inconsistent system. Okay, so why don't you try one on your own? So pause it right now and try it on your note sheet. I'll do this one quietly, so you can either kind of do it on your own and then look up, or pause it and then turn it back on. Your call. Okay, so there's the solution. Hopefully it was no trouble at all for you to get. Okay, so sometimes maybe I'm just asking how many solutions, so you don't necessarily want to take the time and graph them all or graph both equations. We just need to analyze some things here. So I can kind of think of the number of solutions. If I have parallel lines, how many solutions are we going to get? Well, we already talked about that's a no solution. Okay. Do parallel lines have equal slopes? Yes, they do. Do they have the same y-intercept? No, they don't. Otherwise, they would be the same line. Intersecting lines, number of solutions, 1. Do they have equal slopes? No, they don't. Do they have the same y-intercept? Not usually, but they could. So I'll write no or yes. They could intersect on the y-intercept. Same line, number of solutions, infinite. Do they have equal slopes? Yes. Do they have the same y-intercept? Yes, because it's the same line. So thinking a little bit about just y-intercepts and slopes, we can kind of answer these questions. So looking at these ones on the bottom, I can see the slope for both of these is 3, but they have different y-intercepts. So I have a b of 2 or a b of -2. So these are parallel. So I would say no solution here. This time here, you can kind of notice that if I look at the second equation, or the first equation, and I would multiply times 2, I would have 2x plus 2y equals 8. They're the same equation, so it's the same line. Oops. So this would be infinite solutions. Okay. And then my third one, I can right away see that I have different slope. So right away, I know that they're intersecting. So I have one solution. Okay. I could go through and classify these. This would be inconsistent. This is consistent, dependent. If I had to write my answer, it would look like this, or I could have used the second equation. This is consistent, independent. Okay. All right, so the last thing we have to talk about is how do you solve these on your calc? So basically you have to have them solve for y, so you can send them into y1 and y2. So that would be the first thing that I would do. Solve them both for y, put one in y1 and y2, and then we want to graph them. You might have to adjust your window. You should know how to do that. After you graph them, we need to calculate their intersection, so that's second calc, intersect, and then it's going to ask you line 1, line 2, guess, so you're going to have to hit enter 3 times, and then it will give you the solution. You can't necessarily get them to be exact, but you can round them. So I would say we would round them to the 100th, and I would have negative 5.18 and negative 4.05 for this solution. If you are solving graphically with your calculator, your work is still have to be shown. So for this one here, it can be something as easy as just showing me what the intersection looks like. That's all you need to do. So something as easy as this, just to show me that you understand you're looking for the intersections, you threw it in your calc, and I can see that your intersection is somewhere in the 3rd quadrant. Okay, so this is their expectation for that. And then that's all we have for notes. So you should be able to solve graphically, and you should have a couple good samples. See you tomorrow.